We're going to start in with polynomials with this task with Algebra 2. And what a polynomial is, I know this might seem kind of a daunting task, but you can see it's any exponent, and we would call this a degree of n. It's the highest exponent, but they're whole number powers. So the highest power might be cubed. Since we have it here, that would be a cubic. X to the fourth was what would be considered a quartic. And kind of going back, x squared, what we did in previous units with a quadratic, which is a type of polynomial. So it just means many terms. So that's the most general form of what we have up here. And what we're looking at is a few examples of this. And what I like about these examples is that we can sketch the graph, we can circle its x-intercepts, but we also need to explore with a graphing calculator. Before I go to the graphing calculator, though, just notice that there's a few things that it should shout out at you. For instance, this number right here, just like when we did quadratics, is going to be your y-intercept, because if you plug 0 in for x, you will get 8. So notice that what we can do is we can go to our graphing calculator and type in our function. Don't forget about your y equals button. Just a reminder, that's how I got there. Minus 6x plus 8. Hopefully I typed that in correctly. And we can change our window around, because remember that our screen only works for these values. Like, we can't just zoom in with our hands, and it's not your smartphone. So you can play around with your graph, and you can see about what the graph looks like. And as I predicted, it'll cross the y-axis at 0, 8, and you can see it crosses at -2, the x-axis, positive 1, 1, 2, 3, 4, 1, 2, 3, 4, and I think I said 1, 2. Let me double check. And you could confirm that these are correct by plugging in -2 in for all those x's, plugging in 1 for all those x's, and plugging 4 in for all those x's, and see where they cross. We could also play around with the table feature of our graphing calculator. If you hit second graph, and we can see the table, and we can get specific points. So I point out -2, 0, 0, 8, 1, 0, 4, 0, and go on from there. If we, okay, they also ask us to circle its x-intercepts there, there, and there. I'm just trying to follow the directions. So I can do the same thing with the next one, just a few things. It's 0, 9 should shout out at you. I don't know if you're quite there yet on being able to find the x-intercepts, but we have 2x cubed. And if you're curious, if you're afraid that you make a mistake, you can actually hide by unhighlighting the equal sign. So it can be saved in your calculator, but it won't show up. So now if I go to my graph, you can actually see, well, it's kind of tough to see what that x-intercept is, but you can figure that out if you remember we hit second trace and find the 0, and just move your cursor to the left, hit enter, to the right, hit enter, and in between. And notice that it became a red curve because I was on the red equation, -2.42, -2.421 if you round to 3 decimals. And you can see that that curve looks a little bit different. And you actually wouldn't see the x-intercept if you went to the table. Second graph to find that table, but you can get a rough estimate on where things happen. But again, I'm going to circle that x-intercept. And then one more. So if you're afraid that you're typing this in incorrectly, but you have free time to go back to it later, you can just unhighlight the problem and then go to your graph. Whoops. I didn't even realize I made that mistake. Let me clear that out and start over. I'm sure you guys are watching the problem and like, what are you doing? There we go. So hopefully I typed that in correctly, and I can see 0 and 3. So let me circle those. I meant to use my same blue color. And this time I didn't really emphasize the y-intercept. But it should make sense if there's no number over here that you could add 0 to it. And that might help you make sense of this work. So, I don't know if you noticed in this one, but this cubic, sorry, I shouldn't go so fast, but each one of these will be considered a cubic because it is to the third power, the highest exponent. But each one of these had 3 x-intercepts. This one had 3. This one over here had 2, and the one in the middle had 1. But each one of them had 2 turning points. Now here's the thing, not all cubics have 2 turning points. There might be a cubic that just sort of goes like this, where there's not really a turning point. Remember, the fancy math term that I like to use is vertex. But if we're talking about multiple turning points, we call them vertices. And, we can actually determine some zeros from some of the rules we learned with quadratics. And with the x-intercepts being equal to 0, we can approach this problem that same way. And I don't know if you would have recognized this, but you could have factored out a GCF, greatest common factor of an x, out of this. And at this point, you could find factors of negative 12 that add to be negative 1, because 4 minus 3 is 1. Well, to make it positive, make it negative 4 plus 3 equals negative 1. So when I ask you to factor this, that'd be x minus 4, x plus 3, still equal to 0. And so using the zero product property, this could be 0. This one could be, x could be 4, and this x-intercept could be negative 3. So 1, 2, 3, 0, and a 1, 2, 3, 4. And we could find out what our graph looks like. Something like that. Now, for the sake of time, I'm not going to go to a graphing calculator and verify that. So what we could do with the next one is I'm going to use a graphing calculator to find where the largest, so largest is furthest to the right, remember, a root is an x-intercept, and all we know is that it's between 2 consecutive numbers. So as I go to this problem, hopefully I don't mess up like I did the previous one, go into y equals, I'm actually just going to use this one, minus 9x squared plus 12x plus 22. And whether you use a graphing calculator, like the graph part or the table part, you just might want to make your window a little bit larger. So if I hit zoom 6, the 6 option down, I'll get back to the standard window, but it might not satisfy where the roots are. So I want furthest to the right, and I'm just going to count over 1, 2, 3, 4, 5, 6, 7. So between 6 and 7. Now I will point out that you could also use a table, because if we were looking for x-intercepts, or where it crosses the x-axis, we want to see where the answer goes from negative to positive, or positive to negative. And the biggest of those values going from negative to positive was between 6 and 7. So that's how you can use your graphing calculator in a couple different ways. So with the next one, we've done this algebra before, except it might seem weird for you because it's to the 4th power. But the reason why I say it's the same is because think about what you can multiply by itself to give you to the fourth power, and that would be x squared times x squared. And as I do this problem the same way, and I'm trying to get you to FOIL this out, do we have factors of 4 that add to be -5? We sure do, with -1 and -4. And so the reason why I brought out this FOIL thing is to remind you that this trick works because it's -4x squared minus 1x squared is -5x squared. Now I'm going to take this one step further because it's been a while, is that this is a difference of squares. But I did warn you way back when we learned this that we were going to do difference of squares the rest of the year, that when it's a minus and they're both perfect squares, that x and 1 times 1, and to make it a positive is make it negative, make one negative, make one positive. X minus 2, x plus 2. Why? X times x is x squared, -2 times 2 is -4. So as I'm doing this then, I know that my x-intercepts will be at the zero product property would say +1, -1, +2, and -2. And while I'm at it, I might as well even mention that the y-intercept must be at 4. So as I connect these dots, it's going to go up like this, back down, and then back up. And we can verify with the graphing calculator, but for the sake of time, I'm going to leave that for you to explore. And I don't know how far down this goes. My graph might not be all that accurate. And then the same thing goes with this next one, is we have a quartic. Why do we call it a quartic? Is because it's to the fourth power. And we can look at the graph of this. You kind of have a good idea of what the y-intercept is, because it goes up to 70. I'm just going to lamely put that in there. And again, I'm going to go to my graphing calculator and type it in. What I like about these graphing calculators is I can hit second insert and then type this in, x to the fourth power, and then I just sometimes forget to put like the hitting the arrow over, -35x squared minus 39x plus 70. And you definitely want to change your window to have it what it looks like on the problem, going from -10 to 10, but then down to -500, up to 500. And it might help you to count by hundreds, so that way your x and y axis isn't that busy. So as I'm looking at this, if you're confused why I'm counting by hundreds, that's why this is 70 right here. But I think you can pretty clearly tell that we have -2, -7, -7, 0, -2, 0, I'm more worried about the x-intercepts right now. That's why I'm not stressing out too much about how low or how high this graph goes. And then 1 and 5. So 1, and we'll put 5 about right there. So not the best graph, but I'm concerned about these 4 solutions. That's what we call those. And then a reminder that you could rewrite this in factored form. And remember, your factored form is the opposite. So that's why you'll see me write as x plus 7, x plus 2, x minus 1, and x minus 5. And again, I'm trying to keep this video short, but you can double check that this is correct if you go to your graphing calculator and into another equation, type into y2 the same thing. And what will happen is your graph will overlap with a red color on top of it. But I'll let you explore that on your own. And this is the correct answer.